Good morning, everyone. It's good to see some familiar faces in the audience. We have done this talk actually during our portfolio day, so we trained and hopefully it goes well. I will kick off quickly with some fast questions so that we know a little bit what your guys are doing or how big the company is, and then we can go more into the details. So what is Corintis doing?
So what we do as a company is we're really specializing on making microfluidic cooling systems for GPUs and AI chips. So right now, roughly about half the big US tech companies are our customers. And we're mostly working on the ability to put liquid very close to actually where the heat is produced on the chip.
That was already very deep. Maybe back to the basics. When did you found your company?
So we founded it last year. So we actually spun out of the EPFL and CERN ecosystem. And we had some of the big tech companies contacting us, asking if we could commercialize it and they could buy it. And that really led to the creation of the company.
If I'm correct, it's 2 founders. How many employees are you today?
So we're 25 employees now.
That's pretty fast growth in 1 year.
Quite quick, yes.
How do you cope with that?
I think we were quite strategic. We have a very high hiring bar, so we hired people that I think had a large amount of self-autonomy and self-motivation. And I think by selecting for those personality traits, that enabled us to grow the team, I'd say, faster than normal.
And they all sit in Lausanne?
All in Lausanne, yeah.
That's good to hear. So any luck with the funding so far? Yes, we all know Wingman is a investor. How much money did you raise so far?
So right now we raised 3.85 million Swiss francs in our pre-seed round. And with that so far, we were able to get to 5 million in signed revenue. Not all paid in yet, but roughly about half of that's already paid in.
That's quite a lot of revenue.
Yeah.
It should be recurring though, but this is another topic. Can you maybe go a bit deeper on the technology? I think the IP is pretty deep. You even had some nice publications. Maybe you can talk us through how this all came together from a tech side of you?
So it really kicked off with a publication done by Remco, who's our CEO, based in it was a publication in Nature. And he demonstrated the ability to extract 1.7 kilowatts of power from a square centimeter of a chip. Now, to give you some idea, if you went to, say, ChatGPT today, that's running on an NVIDIA GPU. If you zoomed in to actually at the microscopic region of that chip, that produces like hundreds or close to thousands of watts of heat per square centimeter on a millimeter level. In fact, that's so much heat. If you took the chip that runs ChatGPT and put it in ice cold water without any type of heat sink on top, it would boil the water off faster than the water was able to cool it down.
Is it, if I understand correctly, you have a computer chip and you bring water into the chip?
Yeah.
Is it a good idea to mix electronics and water?
So if you ask the industry 20 years ago, they'd say no. But if you actually, there's great announcements. For instance, Jensen, the CEO of NVIDIA, he said every AI supercomputing platform will be liquid cooling by default in the future. And if we already look at our customers, increasingly it's just liquid cooling as standard. So whether it's us or another vendor, we've gone from a world where like an AI chip or GPU was, for instance, 200 watts 5 years ago. Already, as of this year, they're now at 1,000 watts if you look at the NVIDIA Grace Hopper. And the industry is now moving towards 1.5 to 2 kilowatt chips in the next generation. So there's physically not enough heat capacity extraction in air to be able to not use liquid.
So you keep mentioning NVIDIA and other big names. Are these all customers of yours, or why are you talking about them all the time?
We can't, unfortunately, say who our customers are at this stage, but if you look at the top 10 largest companies by market cap, 3 are currently our customers, and we expect to onboard 1 or 2 more soon.
We are sitting on the sustainability stage. So any sustainability in your case? Are you helping the world?
Yep. So if you look at a lot of data centers, I take one example of a data center we spoke to in the Middle East. You have an outside ambient air temperature of about 40 Celsius, say in the summer. They are taking liquid and they're using massive refrigeration systems to bring that liquid down to 9 Celsius. And that's an incredibly energy-intensive process. If you just looked at cooling alone, that's the same amount of power consumption goes into cooling data centers as all of New York and London combined. And that number is continuing to go up exponentially. What we do is we bring liquid very close to the chip, and we direct the liquid to the hottest parts of the chip. And this is much more efficient than basically taking a piece of silicon and using a one-size-fits-all approach. So we can have liquid coming into the chip at, say, 50 or 60 degrees to cool it down instead of at 9 degrees. And with that, you can almost completely remove the need for air conditioning and refrigeration systems in data centers. The other nice thing is you can also get very hot liquid coming out. So right now, if you want to say a big tech data center, you typically have a lot of air coming out at 30, 40 Celsius, and that's just vented into the atmosphere. You can't do anything with it. With our technology, you can get liquid outlets of around 65 to 70 Celsius, which is actually hot enough that you can use it for heat sharing and heat distribution applications.
Maybe one technical question. So you have this chip, on one side are the transistors, and you add these layers or these channels in the bottom. And I know that you do this like in an artwork. You're not having perpendicular pipes, but you do, it looks a little bit like a lung. How important is this strange pattern?
It's very important, because the challenge that you always have is pressure drop. Like you can have a good example, if in your body, it would be ideal from the cell perspective if every single part of your body was just a capillary. But you can imagine how big your heart would have to be and how much pressure it would require to move that same amount of blood through millions of tiny capillaries in your body. So pressure is always ultimately the limiting factor. What we do is there's some parts of the chip, for instance, like the memory, that don't produce that much heat. So therefore, we have very big channels which don't use very much pressure to cool it down. On the other hand, there's the core of the chip, which produces around 10 to 20 times more heat, and that's we direct the flow into very tiny capillaries. So we used to actually do all this design by hand, originally in the labs at EPFL. But then what we transitioned is we built a platform called Glacierware, which is basically runs on a supercomputer, and this shrinks this design process down to just a few hours.
You mention Lausanne all the time. Is Lausanne a good place to start this kind of business, or is there even certain advantages we have here?
I'd say a massive advantage. Like CERN, which is based near us in Geneva, they invested $1.6 billion in silicon-based cooling systems. So there's a huge number of people which have basically been trained and are world experts in this industry that we've now hired and incorporated into our team. We also have about a $200 million clean room on site at EPFL. And our turnaround time, we can literally speak to a US customer in the evening our time, and by the time they wake up the next day, we already have a prototype manufactured. Which for a fabless company, they're amazed at. You know, usually their cycle time is 3-4 weeks.
So you said we have 5 million in revenue this year?
5 million signed. I think this year about 3 million we paid in this year.
Okay, and it's from single-digit type of number of companies.
Yeah.
So maybe look into the future. Where do we stand in 2 years or 4 years?
Right now, our biggest challenge is not so much the sales pipeline, it's really our manufacturing scaling. So we had a customer actually ask, could they buy an order volume that would be worth 15 to 20 million plus, and could they have prototypes this month and have delivery in Q2? But for us to go from, let's say, large-scale proof of concept deployments to filling up data centers multiple times the size of this room is quite a big manufacturing challenge. So our work for next year is really on shrinking that time down, and that will also be one of the biggest factors in driving continued revenue growth.
Maybe one last word about, we did not talk a lot about AI because you are doing hardware, but can you also surf the AI wave, or is this not for you?
Oh, absolutely. I mean, I'd say 85 to 90% of our revenue is directly relating to AI workloads.
How come?
Because AI workloads, they are the most heat-dense computational workloads. Like if you look at, say, for instance, a CPU, typically, if you went on, say, that for Netflix, that might consume 200 watts of power for, say, a high-end chip, when a NVIDIA Grace Hopper uses about 1,000 watts of heat, of power, which then all goes into heat. So our target market, and really where we see the biggest problem, is really in chips running these AI workloads.
We have only 30 seconds left. Anything, it's written on the stage, like you're searching for capital, or you will raise soon, hopefully a big round. Like, why should people come to you and talk to you during this fair here?
I think if you're interested in doing something which helps the environment, but also has a track record of just making a large return, then I think we're very well positioned in that. I mean, I've worked in other companies and built other businesses before, but our ability to go from customer engagement to signing a $1 million contract is faster cycle than any business I've run before.
Thanks so much. It was wonderful listening to you.
Thank you.